Let's talk about algebraic expressions.
Remember to have your notebook out and ready to go. You can always access the learning guide linked in the description below.
All right, we're gonna have you pause the video, start the lesson opener, and then come back, start the video, and check your answers.
Pause, we'll see you soon.
Okay, let's see how you did on the warm-up. A, associative property of addition, because what changed from one side to the other? The parentheses changed their association, what was inside. B, commutative property of multiplication. How did I know? 7 and B commuted, they move spots. So commutative property of multiplication. C, what's happened here? We have 9 times 1 equals 9. So what I started with, I end with. Identity property of multiplication. D, we have negative 11 plus 11 equals 0. So what's happened? I've added the opposite.
So we have inverse property of addition.
And last, how are you doing? We have distributive property because what's happening from one side to the next? We are multiplying in distributing that 3. 3 times x plus 3 times 4, 12. How'd you do? On to the lesson.
Okay, so today's lesson is all about algebraic expressions. So first we're just going to start with reviewing how to translate an English phrase into an algebraic expression. So let's take a look at these. A says 3 more than a number. We want to translate that into an algebraic expression. So we're taking words and making it math. So 3 more than a number. Well, more than, I'm adding, and a number. A number could mean, any variable you want. You could use x, you could use n. I'm going to use n for this one. So 3 plus n. All right, B says the product of a number and 7 increased by 11. Okay, so product is multiplication of a number, so we could make that n, we could make it x, this time I'll make it x, and 7. So I have x times 7, it makes more sense to write that as 7x, comma, increased by 11. Increase, that's gonna be adding, so I have 7x plus 11.
Let's take a look at C. 5 less than a number. Oh, that seems easy. 5 minus x, no big deal. Oh, wait a second, let me check that out. So 5 less than 10 would be 5, but 5 minus 10 is negative 5. Oh, I didn't do that right then. So 5 less than a number actually has to be where the 5 is behind it. So 5 less than a number, so x minus 5. Final answer, x minus 5. Next one, the difference of 17 and a number. This one we're happy about. Difference means subtraction, and we just go the order it says. So 17 minus n, no big deal.
Okay, let's try this last one, E. Let's see if we can get it right. 9 less than the quotient of a number and 2. Okay, less than. We just learned that means subtract from. So I'm going to subtract 9 from the quotient. Okay, remember quotient means division? So dividing a number and 2. So should I use x this time? So x divided by 2 minus 9. Did you get it right?
Wait a second! I did it already, and I put n divided by 2. Can I just use the divide by sign?
No, this is pre-AP Algebra 2.
Okay, you're right. So n divided by 2 using that fraction bar looks so much better, and it's the way that we encounter our equations now. So every time you see that fraction bar, we know that we're dividing by, okay? Let's look at F right now. We're still writing an algebraic expression, but we're presented with a situation. Marvin earns $10 per hour plus 3 cents per widget produced. So let's define variables. H equals the number of hours worked, and W equals the number of widgets produced. Therefore, Marvin's wage will be 10H plus 0.03W. Were any of you tempted to put an equal sign in there? Because I understand that, but we were asked to write an algebraic expression. You'll notice the next line says write an equation for his pay, the total pay. So now I'll write an equation. So P equals 10H plus 0.03W. I want us to start being more familiar with those two words, expression and equation. With an expression, we can simplify, we can evaluate. With an equation, we can solve. We never solve an expression.
Let's get to some essential vocabulary. This course, vocab, is going to be so important. We'll use these math words all year long, over and over again. So this part's extra important. If you need to pause, rewind, rewatch, so that you can get this vocab written down, do it. It's important. First one's term, an expression that is a number, variable, or a product of a number and one or more variables. Term. Let's write down a few examples, like 7, or y, or 13xy. Next one, coefficient. A coefficient is the numerical factor of a term. So like 2x, 2 would be the coefficient, or -4, y, -4 would be the coefficient. Okay, constant term, a term with no variables. So like a number, 7. -3. Constant term.
All right, like terms, we need to go a little bit beyond that Algebra 1 definition. So they have the same variables. We're used to that. 2x plus 3x, 5x. We're pros. Okay, have the same variables raised to the same powers. So what about x squared y plus xy? No, because x squared and x aren't the same powers. Like terms have the same variables raised to the same powers. Let's think of one that will work. Let's go. 2x squared y plus 5x squared y, 7x squared y's. See how easy it is? Let's practice our vocabulary. Simplify if possible, and then identify all of those things that we just talked about. So look at the first one. We have 6t plus 3f plus k. Are there any like terms? No, so it's already simplified. So I want you to pause the video, go ahead and list the coefficients, list the variables, constants, and tell me the number of terms. Pause. Let's see how you did. Coefficients, 6, 3, and did you catch 1? Because 1 is in front of the k. We don't write it, but it's there. Variables, well, we had t, f, and k, so let's just list all 3. Constants, do you see any numbers written all by themselves? No, so write the word none. Don't leave it blank because then we're not sure if you even knew what to do. How many terms? 1, 2, 3. 3 terms. All right, on to the next one. Simplify first, then identify. Look for like terms.
All right, let's see how you did. 4ab plus 7ab, same variables raised to the same power, so we can just add the coefficients, 11ab. Okay, the next one, -3x squared plus 2x. Can I combine these? The power on the first x is 2, the power on the second x is 1, so I can't combine them, so I'm just gonna have 11ab minus 3x squared plus 2x minus 3. That's a constant term. Coefficients, its coefficients are 11, -3, and 2. Okay, the variables are a, b, and x. The constant term is -3, and the number of terms total, 1, 2, 3, 4. All right, now go try that last one totally on your own. Pause the video, try it. Let's see if you got it right. So, simplified form is 3x plus 7y plus 9. Make sure when you added that -4y plus 11y, you added a -4y, not just a 4y. So coefficients to that simplified form are 3 and 7. The variables were x and y. The constant was 9. And then the number of terms total is 3. 1, 2, 3.
All right, here we have a big expression. We want to simplify it so it's more understandable. It's just an expression because it doesn't have like equals 5, so it's not an equation. So all we can do is simplify. We look at that first parentheses and we're just going to keep everything right there. So 2a squared plus 3b squared plus 6b squared plus 5a squared b. Now I realize there's some like terms there, I'm going to get to them. But on this next one, I have a distributive property. It says minus parentheses x plus 4y. And I want us to almost put an alarm here like rah, 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 because we have so many mistakes here. See that minus sign? Everybody's going to get minus x, but do you know how many times students put plus 4y still? It is so important to have that negative distributed to both of the terms in the parentheses. So sometimes it's nice to write a 1, so -1 times x is -x, -1 times 4y is minus 4y. Be sure and get that down. So we have a positive 5 we're distributing into the next one, 3x minus y. Usually not a problem here because we're distributing a positive 5. So 5 times 3x, 15x, 5 times -y, -5y. Now let's look at the whole thing and find like terms. So I look at this and I have 2a squareds. I don't see any more a squareds terms, so I'll just write 2a squared. But the next part, we have 3b squared plus 6b squared, like terms, same variable, same exponent, so that's plus 9b squared. Then I get to 5a squared b. There are no other like terms, so I'll just copy that one down. As soon as I get to -x, I know I have another x term. So I have that -x plus 15x. So -1x plus 15x gives me a positive 14x. And then of course we have -4y and -5y. -4y minus 5y, -9y. How did you do?
All right, for this next one, we have a student simplified expression. So the student got p squared q plus 3p minus 5q. So we want to see if they were on the right track. So we're going to go ahead and simplify this left side to see if we get that as well. So the first thing I'm going to do is, like Mrs. Peart stressed before, I see that minus sign, got a big alarm going off. I'm going to put a little -1 there, and I'm going to distribute a -1 into all 3 terms. So let's see what we have. We have 3p squared plus q plus 2p, that was just there in the original, and then we're distributing that -1, so -5q now, minus p, right? minus 2p squared q. All right, so let's see. If I combine my like terms, if I look, the only like terms I see are that 2p and that minus p. So I'm gonna start off with, oh wait, I have other like terms, 3p squared q, because I have the same variables with the same exponents on those variables. So 3p squared q minus 2p squared q is p squared q, 1p squared q, and then I've got plus 2p minus p would be just plus 1p minus 5q. Is that what the student answer was? No, so I mean the corrected work, or the corrected answer, is what I just said, p squared q plus p minus 5q. So what should be fixed? Well, if I compare the student answer to my answer, it looks like the only difference was that middle term, that 3p versus that just plus 1p. So what could the issue have been?
They forgot to distribute the negative sign.
Yeah, they totally forgot to distribute the negative sign. So instead of 3p, they should write plus p, and then we can explain that they need to distribute that negative sign. Here's our last section. This section says evaluate, and then we have this expression that we're going to evaluate. Evaluate just means we're going to plug in the given values for, in this case, x and y. So A says x equals 4 and y equals negative 2. So we're going to plug in 4 for these x's here, and we're going to plug in negative 2 for this y, and then evaluate using PEMDAS. That's very important for us. So the first thing I see is this negative x squared that I want to plug into, but I have two things going on here. I have a negative being multiplied to x squared, and I'm also squaring x. So two things are happening to x. So I need to be extra careful. So what you might find helpful is, PEMDAS says exponents first. So I'm going to go ahead and wrap some parentheses around that x squared so that I'm not tempted to accidentally square that negative sign. Okay, so we can't forget to multiply by that negative sign. So I'm going to go ahead and start this by writing a little negative 1 outside, and then I'm going to multiply that by x squared, but I'm going to plug in 4 for x. So I'm going to multiply it by 4 squared plus, and then I have 2xy, so I'm going to plug in 4 and negative 2, so 2 times 4 times negative 2, and then minus 7. Okay, so now this next line, I can go ahead and go, well, I know 4 squared 16, and then 16 times negative 1 would be negative 16. For the next set, I would write, okay, I've got 2 times 4 times negative 2. 2 times 4 is 8, times negative 2 is negative 16. So I'm going to have minus 16 when I write this on the next line. So negative 16 minus 7. All right, and then I'm just going to subtract left to right, it looks like. So negative 16 minus 16 is negative 32, minus 7 is negative 39, and we've evaluated.
Same expression, but this time x is negative 3, y is negative 1. So we'll substitute those values. When we do that, remember that negative x squared can be really tricky. So let's write negative 1 times negative 3 squared plus 2 times negative 3 times negative 1 minus 7. And then we'll go back and do the work. So once again, PEMDAS, we do parentheses first. Negative 3 times negative 3 is positive 9 times negative 1 is negative 9. Then the next part, we have 2 times negative 3, which is negative 6, times the negative 1. So now we have positive 6, and then our minus 7. Negative 9 plus 6 is negative 3, minus 7 is negative 10. You've seen two good examples. Pause it. Try C on your own.
Did you get negative 18? Awesome, let's check your math. If I plug in negative 1 for x and 5 for y, I'm gonna have negative 1 times, now remember it's x squared, so parentheses negative 1 squared, plus 2 times negative 1 times 5 minus 7. Okay, negative 1 squared is 1 times that negative 1 that was on the outside, minus, if I multiply the other terms, 10 minus 7. Negative 1 minus 10 is negative 11, minus 7 is negative 18.